Hey everyone, I'm Nick, and this is Bytes of Architecture. So in this episode of the series, we're going to be talking about the basics of multi-threading. So this episode is largely a companion to our previous Bits of Architecture episode on the multi-core era in computer architecture. So if we look around us today inside of our laptops and our desktops and our servers, we see multi-core CPUs. So our desktops and our laptops might have 4 or 8 or 16 cores, and super powerful servers with these chiplet-based CPUs may have as many as 64 or 128 cores. Now, as good computer architects and programmers and performance engineers, we should know a little bit more about the processors that we're running our code on. We should know about how we can write some basic multi-threaded applications, and we should also know a bit about how we can observe these applications while they're running. So that's what we're going to be looking at today. So let's go ahead and get started, and let's learn a little bit more about the CPU that we're going to be running our code on today. And we can do that by running this command lscpu. And we'll go ahead and pipe this through less, just so we can scroll through it. So this CPU is an x86 architecture CPU made by Intel. So you can see the specific model here. It's an i7-9700. You can get some more info here, like the max frequency of this chip, which is 4.7 gigahertz. And you can even see how many cores and threads per core we have. So you can see that this is an 8-core CPU, and we have just 1 thread per core. So we don't have any simultaneous multi-threading or hyper-threading going on here. You can also find a whole bunch more information. So for example, you can find some more about the memory hierarchy of the CPU. So you can see the size of our L1 data cache and instruction cache, our L2 cache, and our L3 cache, right? With those numbers on the right-hand side here. So our L1 data and instruction cache, these are 256 kilobytes, and that memory is spread across our 8 different cores. So there's 8 instances, each of which are 32 kilobytes. For our L2 cache, our total size of all of our L2 caches is 2 megabytes, divided over 8 instances. And then we have a single unified L3 cache that's 12 megabytes. Okay, so let's go ahead and quit out of here, and let's go ahead and take a look at our simple multi-threaded C++ program. So we'll go ahead and open up this multithreads.cpp, and we're going to be using C++ 11 threads today. So down here inside of our main function, all we're going to be doing is spawning a couple threads. So we'll go ahead and spawn 2 std threads, T1 and T2, and each of these threads is going to run our function infinite loop, which is, as it sounds, an infinite loop. So inside of our infinite loop function, we just have a while true. And inside of this loop, forever and ever and ever, we're going to be just creating some value, setting it equal to 0, and then incrementing it 100,000 times, right? And we'll do that over and over and over. So in total, our program really has 3 total threads. We have our main thread here that's going to launch our 2 threads, T1 and T2. And then our main thread is just going to wait for our 2 threads to finish, which will never be the case here because we have this infinite loop, but it will still just be stuck waiting here at this join statement. Okay, so let's go ahead and quit out of here, and let's compile and run this program. So we'll go ahead and quit out of here, and we'll run G++ to compile our program. So we'll compile multiple threads because on my machine, our std thread is actually implemented with pthreads. We have to link against libpthread, and then we'll go ahead and call our executable something like threads. Okay, so our program's compiled now. There's our executable, and we can go ahead and run this. And I'll go ahead and run this with an ampersand afterwards, and this will just make this program run in the background so we can still use our terminal. So we'll go ahead and run that. Right, so it's running as is PID 141680. So now let's observe a bit about our threads that are running. So we can do that through this nice utility called htop. So we'll go ahead and run that, and we see some very interesting things about our CPU. So htop gives us a nice landscape of what's going on our different cores and what processes we have running. So just like we saw through lscpu, we have 8 total cores here. So you can see at the very top here, we have 0 through 7 on these little bars with little dashes in it or little tick marks. You can even see how much memory we're using, the total number of tasks we have, number of threads, etc. And then down here, we have a big long list of all of the different processes we have running and some information about them. And we see at the very top here, we have our 3 threads of our program that we wrote. So at the very top here, we have our main thread, and we see that PID that we saw on the screen, 141680. So this is going to be our main thread that spawns our two threads that come right below it, right? Those are our two threads that are running that infinite loop function. And another nice thing that we can see here is the last thread, or rather the last core that this thread was scheduled to. So we can see here, right, on our two threads that are running those work functions, that they're running on, say, CPU 2 and 1 right now. So you can see these, big blue bars were completely taking up the CPU resources on that machine. But, the Linux process scheduler can move these threads around, right, as it sees fit. So that you might see them move to different cores, right, over the course of execution. Okay. So, one final thing we can do is, from this tool is we can go ahead and kill our program here. So we'll go ahead and just run F9, and we can go ahead and send sigterm to our program to go ahead and kill it. And then we see, our program goes away, and we're just left with all of our other processes, including things like OBS that I'm using to record this right now. Okay, so that's going to go ahead and do it for this time. It's the basics of, multi-core CPUs, how we can, kind of look at some of their features, how we can run multi-threaded applications, and then how we can observe them through something like HTOP. That's going to go ahead and do it for today. As always, I'm Nick, and I hope you have a nice day.